Hello everyone, welcome to the iLeaks video tutorial on a GIS-based delineation of lake basins. We're gonna use the open source GIS software for this purpose. By the way, there are two types of GIS software. Proprietary, such as A-Series or GIS, which we need to pay or purchase to use, and open source GIS software such as QGIS, which are free and we can download, install, and use from the internet for free. And also the source code are accessible for the public use. As we know, there are various open source desktop GIS software available on the internet. Some popular ones are QGIS, GVSIG, Saga, GRASS, or there are many more, such as Jump GIS. These are the examples or the available different open source GIS software. So among these different open source GIS, we can download any of those and use. So for example, when we download and install QGIS, the interface of QGIS looks like this. Uh, Saga GIS, the interface of Saga GIS looks like this. Or the GRASS GIS looks like this. And we basically add data and run different um, functions or tools. And all of these software have their own strengths and limitations as they have been developed for different objectives and have different orientation. So they are superior on their own. However, as a GIS beginner or as a GIS generic user, we'll be using QGIS in this tutorial. Comparatively, QGIS is more comprehensive and has more functions and tools. This is better from the visualization and map making purposes. It's more intuitive to learn and also user friendly. And at the same time, it's less buggy and it has a larger user community and it is more frequently updated. Moreover, QGIS interface integrates other useful open source packages such as GDAL, GRASS, Saga, and also it integrates so many tools and functions as the plugins that have been developed by the user community. That's why QGIS is very useful GIS software, and for this reason, we'll be using QGIS for this tutorial. All right, now let's start the delineation procedure. In this tutorial, I will walk you through the generic steps of creating the lake basin boundary. These are the major steps, such as the preparation of the DEM and running different hydrology and channel tools, and ultimately getting the outputs, mainly in the form of the drainage basin boundary. By the way, this video tutorial is accompanied by a corresponding text tutorial, which you can find as a PDF document right on the iLake website. This text tutorial also walks you through the same steps, and these steps have been numbered and they have been illustrated with appropriate graphics throughout the document. And throughout this video tutorial, I will be referring to these different number steps time to time. Since this is a GIS-based delineation procedure, the very first step is to obtain or to find, download, and prepare the digital elevation data, or simply the DEM data. There are various sources of DEM data. For example, we can obtain good quality, high resolution data from the local sources. And also there are multiple web sources for the DEM data. For this tutorial or in this exercise, we will download the DEM data from the Earth Explorer website run by the USGS. But before we proceed with the download, let's create a workspace where you will save your various data files, as we'll use different file types and we'll be producing different intermediary and final outputs. It is very important to organize and manage the data files. That's why it's a good practice to create a workspace and then ultimately create subfolders as needed to save and manage the data sets. So for this purpose, let's create a folder by using the File Explorer. So go to Start button and File Explorer, and you can save anywhere like in desktop or anywhere. For example, in this case, let's create a folder in Documents folder and right click and New folder, and let's give a kind of descriptive name. So for example, uh, Basin Delineation folder, and we can create subfolders within that. So for example, we can create a lake folder to save the data for the lake of interest, and in the same way we can create another folder called elevation. So we will save the layers or data we download from the website in those folders, and you can create multiple subfolders as needed. And creation of this workspace refers to the step 1.1.1 in the corresponding text tutorial. Now let's go back and start downloading the data. So to go to the Earth Explorer data, simply let's Google. So the first link, and it takes us to the USGS website uh, for Earth Explorer data. Actually, this is very useful website, and we can find very useful data sets from this website as well. But one thing we need to do is we need to log in. In my case, I'm already automatically logged out because I have already used this multiple times, but you need to log in. Simply, you can create the account and just log in. Only then it allows us to download the data. So once here, we need to know which lake is the lake of interest, meaning for which lake we are creating the basin boundary. In this case, in this tutorial, let's take an example of any lake, but let's take the example of Lake Volta from West Africa. Actually, this is right here in Ghana. So let's take an example of this one. So our purpose over here is we want to download the DEM data or the elevation data from this area. So first we want to find out the tentative watershed area. Maybe for this lake, I think this is, we can imagine, I mean, you can simply guess this can be the area. So let's tentatively select this area. The first thing over here we can do is the search criteria, and in search criteria click the geocoder. Actually this is the default already selected, and then now when this is selected, what we can do is we can create the points that define the extent. Okay, so maybe from here it may go up to, let's say, over here, maybe up to here. Okay, So once this is the tentative area, like watershed area. So we selected. Now we want to select the data sets, and there are multiple data sets actually, but our focus is on the elevation, right? So elevation, and even for elevation, there are different sources. So SRTM, very commonly used, and again, void fields like the gaps and gaps and no data areas kind of fixed over here. But because this is a pretty much bigger area, that's why we need to download multiple like SRTM tiles, and actually it takes a little longer time. So just for the demonstration purpose, I am selecting this dataset, which is GMTED 2010. Okay, so I select that data and then go to results tab. And if you click results tab, it's selected like these four DEM tiles. We can select like, hey, what are the locations? So this one, that one there, that one there. Wait a second, where is that? Oops, I didn't click that. And this one. So we have four tiles. So what we're going to do is we're going to download these tiles one by one. So go to this and download. You can download very finer resolution, but again, this may take longer time depending on the size of your watershed. You can choose any, but for now, for the convenience and the processing time, we'll download the tiles with the coarse resolution. Okay, so I download these. Once the download is complete, we can simply go to our workspace to save it. Go to Start button, File Explorer, Downloads, where it automatically resides. Then copy this and then go back to Documents where we have created our workspace called the Basin Delineation in our previous step, and then we want to save within the elevation folder. So double click and just paste. Or alternatively, we can create a new folder to save the data. So let me go and in my case, let me create a folder, new folder. Let me say over here, new folder, and I'm giving a name, something like I like tutorial and I'm saving over, oops, let me do this. Okay, so then I download this one by one. So just I download this and again select this one because we want to select all of the same resolution. Okay, so download this like that, and you want to do all these four one by one and save there. All right, so once I have all these four tiles downloaded, I will be just closing this and I'll unzip those one by one, or we can do all together. So this one I'll be You can use extract all, but I'm using 7-zip all. This one, and so this one also, this one. Okay, so I downloaded the DM data. I unzipped, and this ends the subsection 2.1 from the text tutorial, or it refers to the step 1.1.13. Now we are ready to add the elevation data on a GIS, and in this case we are using the desktop QGIS. And obviously you should have the QGIS already installed in your machine to proceed. If not, you can download and install now. You can just Google saying download QGIS and then go to the documentation page and you can proceed downloading, looking at this. Or you can simply get help if needed from these different video tutorials on how to download and install QGIS. But again, for us to proceed, you need to have the QGIS installed in your machine. Okay, so now let's start uploading the data and then going through different geoprocessing steps to delineate the watershed boundary. Okay, so in my case, I have already installed QGIS, so I'm just opening QGIS. Uh, for this date, this is the latest version, and I'm opening QGIS. Oh, all right, this is not the new. I mean, they already updated another version. Wow. Okay, all right. Anyways, so the next step is to add these 4 different DM tiles into this QGIS um, document project. It is called the project. Okay. So there are multiple ways to add. You are maybe, or you are already familiar, or you may see on other basic tutorial videos as well. But basically, I go to home and simply expand, for example, my data I have saved in desktop and I have saved on iLake task. I have created iLake tutorial and the data are over here. Okay, so the first tile I expand this, and there are actually multiple tiles. So that's how this GMTED data come. But among those, it says the mean. So that mean layer gives, I think, the mean elevation value for that particular pixel. So let's select this and add, and also do for another tile. So let's add the mean again, and also for this one, and let's find mean. Okay, and also for the another tile, let's add mean. Okay, so we added all these 4 tiles, and actually our area is over here, and by chance this is where all these 4 tiles meet. Otherwise, just one tile would be enough for that, for the delineation purpose. Okay, now let's save the project. This QGIS document is called project or QGG file. So to save this project, click Project and Save button. Or simply you can click this Save button and then navigate to your location. So in my case, so I have Lake Tutorial and give a name, something like Basin Tutorial. Okay, so it's a good habit to save the project and also click this save button time to time. And this would be useful if the computer crashes or QGIS closes by accidentally, or if you have to stop now and you want to resume the work later. Now you can close this, and then if you need to open this again, you can do that so easily. So for example, I go to the same folder, um, and for example, I have this, and I have iLink tutorial folder, and I have saved that over here in this QGG file. If you double click, it opens exactly the same. In our text tutorial, this refers to the step 2.2.1. So once we are able to add these four tiles, the next step we want to do is to merge these three different layers, or four different tiles into one raster layer. Okay, and in QGIS, we'll be doing, or we can do that in multiple ways, but the very handy tool is the merge tool. So we can go to raster, miscellaneous, and then merge. Or if you don't know, actually, you can simply search over here, merge, and oops, and we can find this over here. Okay, so these are the, I think, same, but again, we can double, if you double click, the merge catalog window opens. So in this window, what we want to do is we want to select these four layers. So we want to mosaic, or we want to actually combine, or in a way, in fact, combine is not like overlay, but again, these are kind of merging, like, one attaching to other. Okay, so we are selecting all these four because we want to merge all these four, and I'm hitting OK. And in this case, we want to leave all the parameters as it is. We will go with we're good with the default parameter values. So simply go and save to our folder. So save to file. And in my case, I have created this iLink tutorial, and I'll be giving a name, merge DEM. So it's a good practice to give a little bit meaningful descriptive name so that we can track what steps we followed or which layer is what. So save and then ultimately run. So when we run, okay, in fact, it's already finished and merged is over here. So if we turn off these, actually this is all now combined one layer, right? Merge just one. And this completes step number 2.2.3 from our text tutorial. Okay, that's what I said. This is a little bit, I would say, little bit uh, bigger size DM because it covers all the area. right? Almost half of the Northwest Africa. So we want, because in the coming up processes, we want to downsize this. So we want to make this a little bit smaller raster. So what we can do is we can clip it. Okay, we can clip only this area, right? Because I think our water set is not going to be bigger than that area. Okay, so what we can do is we can go to raster and then we can extract, but we can actually extract by the extent. Okay, clip raster by extent, and then in this case the input layer is going to be definitely the big DEM, and we want to clip by drawing the rectangle actually. So I can draw for the tentative area. For example, let me use this much area. I think should be enough. Okay, and then simply I go down and save it. Okay, so this is going to be merge DM, but it's the clipped. Okay, so I clipped, run, and it's already added, and in this case only for this area. So even we can move or even remove all these raster not to be confused. So I want the very cleaner canvas. Okay, so I'm removing everything because this is what we need, and I'm zooming to the full extent, and this is our location. Okay, so now this is the DM. So finally we have the DM. So if you have a DM from let's say other sources, then you can skip these steps so far, and you can just add your DM and then start the steps I'm going through. Okay, so if we refer to our Word document, we completed the step 2.2.4, or downsizing the raster. So now, because this DEM is kind of raw, right? It may have different sinks, and these needs to be filled actually, and that's how we have to create a hydrologically conditioned surface or DM. So for that we need to fill all the possible sinks, because they are normally the problems in a DM. So here we can use the Saga tool. So simply we can go to Saga right over here, although all other other tools are available, but go to Saga, expand this, and what you can do is we have in Saga like toolboxes. We have multiple, toolboxes, and in the toolboxes there are multiple tools, right? So go to hydrology, and then we have the three different versions of the field sync tool. Okay, and in this case I'll be using, they do more or less same task, right? But again, for me, this is the most updated version, I guess. That's why I'll be using this. So click the fill sinks, and we want to fill the sink, which is the clipped. Definitely, this is the only available DEM, right? And then I'm again going and giving the name simply like filled DEM. Okay, so filled DEM, and I'm just running it with all other parameters leaving as the defaults. Okay, because we downsized the DM, so it shouldn't take a long time. It should be pretty fast. Okay, it's complete and it's added the same DEM. So in this case, actually not much difference among those. So now this is kind of, hydrologically conditioned DEM, and now we can input this for all hydrological and channel tools, such as like, creating the channel networks or any of the hydrology tools. Okay. So next, for our purpose, the next tool we want to use is actually from the terrain analysis channels toolbox. And there is one tool called the channel network and drainage basin. Okay, so click this, and we want to definitely the elevation layer is the field DM, which is the corrected DM, right? By using, and we don't, well, it creates multiple actually outputs, but we are interested only on the mm, the stellar, yeah, stellar orders, and maybe the channel networks. Okay, so let's uncheck these other. So uncheck the flow direction, flow connectivity, but let's save this stellar order. Okay, so I'm going and naming order, and then we don't, for now, well, you can see, we can check it, but again, we don't need. So I am not this, but I'll be saving this. Okay, channels. I'll be giving the name channels, and we don't also need these. All right, so I'm saving only the stellar orders and the channels. Okay, and I'm running, and hopefully it runs pretty fast, and let's see without any errors. Okay. All right, so this is complete, and it added these channels and the stellar orders. Okay, so these are the channels. So it doesn't find any river paths like in these areas. Well, it seems like, looking at the DEM, actually, it should be, I mean, these are the stream networks actually, but we don't see why. It maybe for the rivers it captured only, but look at the stellar order. Okay, stellar order we can see some, but it seems like, some of the paths are kind of confused. So this may be because of the algorithm of the field, I mean field sync tool. But again, so looking at this, I mean stellar order, we can find the image like this. And we completed step 2.2.8 from our Word tutorial. And we think our lake is somewhere here, right? Obviously. And we want to create the basin only for the um, Lake Volta, right? So one thing we need to do is actually we need to find out the outlet, the pour point of Lake Volta, meaning we need to find out one point through which all the water from that watershed drains out. Okay, so to locate that, we can use different references. You can, if you have the lake like save file, you can add over here and then you can overlay and find. But in QGIS, we can use the base maps. So if you go to web, this tool, and then maybe different quick map services. By the way, if quick map services are not available when you click on the web, for example, if there is no option for that, then it means that quick map services are not installed in this, because they are the plugins and we have to install. And to do that, you want to click plugins and then manage and install plugins, and simply type something like quick plugin. I mean quick map services, or simply go down and it's over there. So when you select this, it says like it's uninstalled. That's why we just want to install. Okay, if you click install plugin, it's just installing and it's now available. So if you go back and click on web, and then now these services are available here. So you can simply choose any of the base maps. So for example, OSM is standard. It simply adds the base map. And obviously you have so many different options as well. This is the base map, like the global map, right? So, and this is Lake Volta, we know. And we know that we want to find out, hey, what is the outlet point? Uh, because we know this is not the indirect or the not the closed lake. That's why definitely it has one like outlet, right? The pour point. So let's suppose that this this barrage, or I don't know, this dam is the pour point, for example. Or let's say, I don't know, this breeze as the pour point. Okay, we can take this as the pour point, or you can take any pour point. So we want to know, or we want to locate and capture the XY coordinate of that pour point location. Okay, so if we add structural order layer, this also shows the main channel, right? See these very light, very white pixels, or the cells that have the high accumulation value, meaning the water flows through them. Okay, so then what we need to do is, if we think, let's say, if we think this is the pour point, let's say, where is the, okay, this can be the point. Okay, this can be the point. All right, so what we're going to do is, let's see again more. Wait a second, this is not, or let's say, let's think, well, this, okay, so this is over here, is, let's say, this one of those. Okay, so let's take this as the outlet point. So we want to capture the actual location of this, so that we can use these values as the input in, what is it called, the watershed tool, or the upslope area tool. Okay, so in QGIS we can simply right click over here and copy the coordinates, and we can simply copy the displayed displayed CRS, meaning coordinate reference system. Okay, and copy, and then maybe save somewhere, maybe notepad. I'm just pasting because we need to enter these values in the upslope tool. Okay, so the next step is to create to delineate the watershed for Lake Volta, and we have the tool, and its name is upslope area. Upslope area under the hydrology toolbox. Okay, so if we double click and open this, it opens like that. The dialog box for upslope area looks like that, and definitely our target area, we don't use the target area if this is the indirect lake. For example, your lake is indirect lake, and then what you can do is you can convert the lake into a raster file, and then you can use as the target area as well. But in this case, we'll use the target XY values, and actually this is just optional parameter as well. Okay, so X value is this guy. I'm just copying and pasting, and this is the Y coordinate. So Y, and then elevation would be our field DEM, and then the method should be, which is the mandatory parameter. So we want to choose, uh, so we can just select the first one and then ultimately go down and save. So I can save this as I can say up slope area, or this just the watershed. Okay. Oops, it seems the target X coordinate value is 0, 0, 0, but please make sure this is the actual value you copied and pasted. So if we run this, hopefully it doesn't give any errors, and it's pretty fast. Yep, it is complete. Okay. Okay, so this is the result of the upslope area, and this completes the step 2.2.10 from our text tutorial. Okay, so this is the upslope area, but this is again in raster format. So this is in raster format. So we want to convert this into vector. So we can do that in multiple ways, but this is very straightforward. So raster conversion, and we use the polygonize, right, raster to vector, and definitely upslope area. So this is the band number 1. That's okay. DN values, and vectorize, we don't do anything but simply save. Okay, so I'm saving as the save file, like vector data file, and I'm giving name like Basin polygon. Okay, so we are converting into polygon, and it's complete. Yep, it's complete, and it is added. So if we look at the attribute table, yep, it has 100, 100. So these 100 value, okay, this is the watershed boundary. So basically, right? So we want to only this. So I selected. So if I export this, save as this only the selected features. That's how it saves only this selected polygon because this is the this is the polygon of interest for us. So selected features. So I'm to save as the S3 save file, and file name will be, I'm going over here, tutorial, and I'm giving the name polygon save file, but like Volta, and we just leave it and just hit OK. So now it created just this lake, right? Sorry, lake basin. And yep, so we can change some colors and styling. So if we go to the symbology, so we can simply say like no color, or fill would be no brush, so it would be hollow so that you can see the below area, and maybe this color would be something gray, or this one a little bit bigger, stroke width a little bit bigger. So that's how it looks. So this is the watershed boundary for Lake Volta. Okay, so this is a very simple, straightforward procedure to delineate a lake basin. On top, we can add the river channels. So we can change the color, or we can simply clip only within, only within the lake area. So we can clipping. Okay, polygon clipping. In this case, we want to clip by Lake Volta. Input features would be the channels, and then output would be the channels in Lake Volta. Okay, so it's clipping. All right, so it's done. And so channels. So now we can show only these. And if we click, the color can be something like maybe blue. And we can show like, hey, these are the river channels, and this is the, this is the boundary according to the tools we can find in Saga toolbox. All right, and hopefully this gives a kind of uh, major steps, although each step may have other options and there may be other rooms to explore, but this tutorial just gives a kind of very generic major steps to delineate the lake basin for a lake. All right. Um, Thanks for your patience, and thank you very much to watch this video clip. Have a good one.